Good morning, guys. Mr. Milton here. Today we're going to talk about rationalizing the denominator, kind of a continuance of our fractions practice. Okay, at the end of this lesson, you should be able to convert a radical to simplest radical form by rationalizing the denominator if necessary. Okay. All right, since we've done simplifying radicals for a little bit now, just kind of want to make sure I throw out what simplest radical form is. Simplest radical form means that there are no perfect square factors other than 1. Okay, that's why we make our tree and take out all the pairs. Okay. There are no fractions inside the radical. Okay, so if we have a fraction, a radical in the numerator that's of a fraction, that's fine, but it can't have a fraction underneath the radical. We did that yesterday. And then the denominator of a fraction is not a radical. Okay, hopefully we didn't run into too many of those yesterday, but today we're going to address how to make sure that the denominator is never a radical. Okay, with what we learned yesterday, we could potentially run into that situation. Hopefully we won't do that now. All right. Let's start off with the first example. We have 2 over radical 5. Okay, this is not in simplest radical form because, well, we have these first two checked off, but the denominator is a radical. Okay, we can't write it this way. I don't know why. I don't know why the reason that you can't. No, people just don't like the radical in the denominator. Okay, so when you ask me, hey, Mr. Milton, why can't we write the radical in the denominator? Because some math person higher than me said never do it. All right, and we know how to get around it, so we will. All right, so what we want to do is we want to address this. We want to get rid of this radical without changing the number. Okay, and the best way I know not to change the number is to either multiply it by 1 or divide it by 1. Okay, because multiplying by 1 and dividing by 1 doesn't do anything. But in this case, there's a way to multiply this by 1 that helps us out and doesn't change what the value of the number is. It just changes how it looks. Okay, and I call that fancy 1. Okay, so we're going to use fancy 1 here. What would be really nice is if I didn't have a radical here. If this was like, let's say, a perfect square instead of radical 5. If I could just simplify this and make it a perfect square, that would be the best possible choice. Now I'm thinking that if I multiply a radical by itself, if I multiply any radical by itself, I make it a perfect square. So that's what I'm going to do here. I'm going to multiply the denominator by radical 5. The issue is that if I just multiply the denominator by radical 5, I change the number. And so this is where fancy 1 comes into play. If I multiply the denominator by radical 5, I'm going to multiply the numerator by radical 5. Okay? And if you just look here, you will see radical 5 divided by radical 5 is 1. It's 1. Looks all sophisticated and all, but it's still just 1. So that's why I call it fancy 1. Okay? It's all dressed up, but it's still just 1. So we're going to multiply it and see what happens. Got 2 radical 5 in the numerator. What do we have in the denominator? Radical 5 times radical 5 is, you can say radical 25 if you want to, but shorthand, when I multiply a radical by itself, it kind of just gets rid of it. So radical 5 times radical 5 is 5. Okay. And here's our answer. Check to see if we can simplify it, but 2 and 5 don't divide evenly into each other. 5 is inside the radical, and this 5 is outside the radical. And remember, our rule is inside by inside, outside by outside. So we can't mess with these two together. So this is our answer. Alright. Alright, number 2. For this problem, we have radical 7 over radical 8n. Again, we have a radical in the denominator. Now, something that people just want to do, since we talked about fancy 1, you could just run out and multiply by radical 8n over radical 8n. Okay, that works. Sometimes people prefer to simplify this. Okay, 4 times 2. 2 times 2. I should have probably just done 8n. Anyway, I'm going to simplify it. And I get, in the denominator, 2 radical 2n. Okay. So radical 7 over 2 radical 2n. I still have to do the same thing. Okay, I still have a radical in the denominator after I've done that. So now I need to get rid of this radical. I'm going to get rid of this radical by multiplying by fancy 1. In this case, I'm going to use radical 2n. Okay, and I do that because radical 2n times radical 2n is just 2n. So I have 2 times 2n. Remember, our rule is insides by insides. So it doesn't multiply by the 2, it just multiplies by the insides. Radical 14n. Okay. These are both radicals, so they can multiply together as well. Okay. And so now as I'm simplifying it, I have in my numerator radical 14n, and in my denominator I have 4n. Okay. Can I simplify these? No. Even though we have an n and an n, this is inside of our radical, this is outside. It's only outsides by outsides, insides by insides. Same with the numbers. Even though both these are numbers, are even numbers, 14's inside, 4 is outside. Can't mess with them. Okay, and so this is our final answer. Alright, number 3. We have 3 over radical 3. Alright, can't simplify radical 3 any. Okay, we want to get this radical gone, so we're going to multiply by fancy 1. Radical 3 over radical 3. Okay, again, call it fancy 1 because radical 3 divided by radical 3 is just 1. When you multiply a number by 1, you don't change the value of the number. Okay, so this is our way of changing how the number looks without changing the value of the number. Okay, so let's multiply that. Got 3 radical 3, because outsides by outsides, insides by insides. There's nothing outside or that 1 outside. If you want to think of it as always having a radical 1 by it, you could. Okay. In our denominator, we have radical 3 times radical 3, which is just 3. Okay, you could say it is radical 9, but radical 9 simplifies to 3. Okay. Alright, and now for this problem, we have 3 radical 3 over 3. And so like I said, we should look to simplify each time, and this time we can because we have a 3 on the outside up top and a 3 on the outside in the denominator. And so when we simplify it, we just have radical 3 left. And so that's our answer. Alright, one more problem that balances on my notebook. Got radical 5 over radical 18t. Okay, again, I'm going to simplify this. 9 and 2, 3 and 3. I have 3 radical 2t in the denominator. In my numerator, I have radical 5t. Need to get rid of this radical in the denominator, or else it will not be in simplest radical form. So I do that by multiplying by fancy 1. It's radical 2t over radical 2t. Okay. My numerator, they're both inside the radical, so I can multiply them together. Radical 10t squared. My denominator, I have 3 radical 2t, so I have 3 times what will just be 2t. Okay. My numerator, I notice I have a squared variable. Okay, I know I can take that out. It's t. 6t. Okay, in my numerator, I have 10. If I break that down, that's 5 and 2. No pairs there, so 10 just stays inside. So t radical 10 over 6t. I always look to see, can I simplify? In this case, I can. I have a t up top and a t in the bottom. So I simplify, I have radical 10 over 6. Okay, Again, I cannot simplify here because one is inside the radical and one is outside. Only insides by insides and outsides by outsides, so these don't mess with each other. Okay. All right. So that's the lesson, rationalizing the denominator. Making sure that you keep it in simplest radical form. You should have what all that means. No perfect square factors other than the one underneath the radican. No fractions inside the radical. And then the denominator of a fraction is not a radical. Today we talked about how to make sure if we got a radical on the bottom, how we can get rid of it using fancy one. Okay? All right. See ya.